Alright, hope everybody's doing well. Hope everybody already voted, preferably before today, so you don't have to go out in the rain. Alright, well, I want to talk about ODP 414, 418, and then talk about your next programming assignment, which I posted about an hour and a half ago. So let's start off with 414. So 414 was this assignment where we were mixing two strings together and interleaving them to create an output string. And we went through some pseudocode for that yesterday. Let's take a look at an implementation of that. So this is pretty direct from the pseudocode that we spec'd out. Basically two input strings and output string, and loop through all the characters in the input. S1 and S2 have the same length. And I'm building an output string called out, and so I have an index that I initialize to 0 that always shows me where my next character should get stored in this output array. So initialize to 0, and then as I march through my input, copy from first S1 to my output, and then from S2 to my output. And I'm doing a post increment here, so after using the current value of outloc, it gets incremented. So this is just like after my assignment saying outloc equals outloc plus 1. So that's just a post increment. And that loops through all the characters in the two input strings, and then when you're done, output location should be where the next character would get written. Well, the only other thing left to write in the string is the null terminator, so we just copy that to output location, and that terminates our string. Check your edge cases if my input strings are empty, meaning they have a length of 0. This for loop will never fire because inloc is 0. It runs as long as inloc is less than 0, which never happens. And so nothing happens in here. And our whole program simply says set outloc to 0 and set out bracket 0 equal to the null terminator. And that's the correct behavior for, mixing two strings that are both length 0. It just creates an output string of length 0. Alright, so 418, we're doing something different. We're still taking in a string, processing it, and creating an output string. But this time what we're doing is basically shifting the string to the left. So if, for example, our input string is ABCD, we want our output to be BCDA. So shift everything over to the left, and then this character on the leftmost position, that gets shifted to the rightmost position. So engineering 270, this is a rotate left function, right? Rotate left with no carry. Alright, if you were to pass this a single string, a single character string like this, right, it would leave it unchanged. If you pass it an empty string, you get back an empty string. If you pass it a string with two characters, you get back those two characters in the reverse order. Okay, but all those operations can be understood as simply move each character to the left, take the leftmost character, put it in the rightmost position. All right, so how do we pseudocode this? Same basic idea. Let's build an output string. So let's have an output location initialized to 0, and let's iterate over the input. right? So for I goes from 0 to string length of your input minus 1. So your usual, I equals 0, I less than string length, I plus plus. And what we want to do in here is basically out bracket. Well, this first character is an unusual case, right? This first character is going to actually go to the end. So let's iterate over indexes 1 through string length minus 1. And we can say out bracket, out location plus plus equals in bracket I. Alright, so when I is 1, this is character 1, that's going to go in output location 0. And we'll increment outloc to 1. I will increment to 2, we'll copy character 2 to the next output location, which is there. We'll increment I equals 3, we'll copy character 3 to the next output location, which is there, and we'll increment outloc. And when we finish this, again, outloc should be the point where we would write the next string in the output. Well, what goes in that next position in the output? Just the first character in your input. And then add your null terminator, as usual. So something like that should get you most of the way there. Check your edge cases. Right? So if my string was a single character, string length is 1, this will loop from 1 to 0. It's never going to execute my for loop. This is just going to say out bracket 0 equals in bracket 0, which is A, and it'll increment outloc to 1, and then out bracket 1 will be the null terminator. That's going to work great. Check your other edge case. Empty string, string length equals 0. So we'll set outloc equal to 0. We'll never execute the for loop. This will say out bracket 0 equals in bracket 0, which is a null terminator, and it'll increment outloc. This is going to say out bracket 1 gets set to a null terminator. That may be a problem. If there's nothing in this input string, we really just want the output string to be empty. But as this code is written, it's going to load 2 null terminators into my output, and that may not be something I want to do. Right? Now, I don't think the assessments that I'm running actually test the case where out only has a single byte available. But to be really correct about this, probably throw in an extra check here. If in is an empty string, then just set your output string to be an empty string and return. So string length n equals 0, set output bracket 0 equal to a null terminator and return. Something like that. Alright, so the basic loop is, pretty straightforward. Just shift everything down one spot. The wrapping the first character to the last, if you're careful with it, is pretty straightforward. Null terminator, if you're doing an output location, just pop it onto the next output location. There's other ways you can do this, though. You can try to shift this thing in place, right, and save that first character somewhere first. You could try to shift it in place from the right to the left. There's all kinds of things you can do. This is a very straightforward approach. Let's see, function prototypes expects an int for the return, but it's all the pointers. We don't have to return anything. Yeah, you can just return 0 or just return whatever value you like. Since it doesn't specify what that returned integer should be, doesn't matter what you return. And the rest of this is all boilerplate, right? So you can use string length, don't use any other built-in functions. Test your program with your own test bed, and then compile it with the assess test bed and assess it as usual. Why use Outlook ++ inside the brackets? So general notion. Right, so saying out bracket Outlook ++ equals blah. That's the same thing as doing this. Out bracket Outlook equals blah. Outlook equals Outlook +1. So it's saying go ahead and use the current value of Outlook, but after you're done using that, go ahead and increment it. So that's called a post increment. And the other version of that would be something like this. If you do a pre-increment, this is analogous to the following. First increment the value of this output location and then use it in your assignment. So it's just a shorthand. All right, other questions about this? All right, let's talk about homework 7. Let me talk about something else first. Let me talk briefly about string comparisons. And this came up a little bit in homework 6, and it may come up in some of the other stuff we're doing. So I just want to mention something. When you work with strings in C, remember if I have a string like quote hello or car star X or car B bracket 10, right? When I have a string, whether it's a pointer to a character, whether it's an array of characters, whether it's something inside quotation marks, the value of that, right? The value is actually an address. So if I were to print this out as a %x, I would see something like, 0x420,138. If I were to print out the value of x or the value of b as an integer, I would see some number like that. Okay? Strings are really just addresses in memory. Well, we find that address is the set of characters that make up that string. So here's some code that we might be tempted to write. So I'm going to ask the user to say hello. I'm going to do fgets to read some input into this array buffer. I'm going to print it out here inside angle brackets to see what the person typed. And I'm going to say if the person typed hello followed by a new line, let's say good. And if I run this and I say hello followed by an enter key, my buffer is definitely hello followed by a new line, but it says bad instead. Right? It says bad because my buffer is not equal to hello new line, even though that's what it looks like I typed in. Okay? Because this comparison is actually comparing addresses in memory. It's actually saying, let's look at the address of this character array, let's look at the address of this string and see if they're the same. And since they're not the same, then the condition fails. All right. So how do we compare strings? There's a string function called string compare, strcmp. That's the proper way to compare two strings to see if they have the same value. All right. So you can look at the manual page for this, and it will tell you it takes two string arguments, s1 and s2, and it returns either something negative, 0, or positive, depending on how those two strings compare to each other. So it basically compares them alphabetically. So if I compare cat to dog, cat comes before dog, string compare would return a negative number. If I compare dog to frog, or dog to cat, right, it would return a positive number. If I compare two strings that are exactly the same, it'll return 0. So the way I check to see if two strings are equal is pass them both to string compare and see if it returns a 0. And if it does, then I know those two strings are the same. So here if I say hello and I enter a new line, it'll tell me those are the same. If I have some extra stuff at the end, they'll be different. If I have different cases, it'll be different, and so on and so forth. Alright, so string compare is the best way to compare strings. Like so. This can get confusing. So here I've got two strings that are, obviously exactly the same. Hello \n. I'm going to see if that's equal to hello \n. And I'm not using string compare here, but that actually tells me that those strings are the same. So, sometimes a double equal sign works correctly. And it is actually doing a legit comparison, because if I try to compare it to lowercase hello, it'll tell me those are different. Here's a case where I have two character pointers. These are different variables. I set them both equal to quote hello, and I check to see if they're the same. Well, since they're different variables, and I've said that comparison doesn't actually look at the characters, it just looks at the addresses, we might think that these would actually end up looking different to the compiler. But in fact, those are exactly the same. And they're the same because when we compile our C code, the compiler sees a quoted string here and it says, okay, I'm going to put that somewhere in memory. And it notes where it is. It's some weird memory address. And it sets b1 equal to that address. Well, later on, I ask it to set b2 equal to the string hello new line, and it says, hey, I know that string. I already put aside that value in memory somewhere. Where was that address? It finds the address of that, and it sets b2 equal to that. b1 and b2 are the same address. Here I'm going to copy a string hello into my buffer, and I'm going to compare that to hello using an equal. And that's not going to be the same. And why are those not the same? Because this is the address of this character array. This is the address of a string that the compiler set aside somewhere in memory. They have the same characters at that address, but the addresses are different. So the equal will fail. One more example, back to the one where I had two variables both pointing to hello. If I try to change one of those characters, like set the first character of b1 equal to a question mark, that's going to throw a seg fault. Because when I have a quoted string in C, not only does the compiler create an area of memory, right, set aside an area of memory for these characters, load these characters into that area of memory, take the address of that area of memory, and assign it equal to b1 and b2, that area of memory is protected from modification. It's read-only. So if I try to update the contents of that, like setting the first character to a 0, I'll get an error. So that's a seg fault. Alright, so that's just some stuff to be aware with strings in C. it's one of these areas where ideally you can be thinking from time to time of what's going on at the hardware level, right? We're writing C code, that's a very high level thing, but it's really not. Particularly when we deal with pointers, which is what strings are, we're actually working pretty close to the lowest hardware level, right? And being able to think about what's going on in memory when we, write something like this. Right? Being able to think about what this means memory-wise, where is this, where is that, will help us with C, and it will help us a lot in winter quarter when we get into data structures. Because 222, data structures in winter, we're just going to be working with memory. We're going to be manipulating memory at a very low level by using pointers and dereferencing pointers. And we're going to need to be able to think about what's going on at the hardware level. And so GDB will come in key ways for all of that. So this is just a chance to kind of think about some of those things. Let's see, ODP question, cannot run program move. I would say you either did not compile your program, or you compiled it and called the output something other than move, or you got compile errors and it did not create a program move. So I would say check your directory, make sure you have a program named move in that directory, because that SS error is saying there's no such program. Okay, so now we can talk about homework 7. Move can return any value that you want. It doesn't specify what the integer value should be, so you can just return 0 if you like. Alright, so homework 7, this is your next large programming assignment. It's going to be written in Bash, it's going to be GUI based, and it can be a group project if you like. Okay, so some fundamental differences from previous assignments. So let's run through the details of this, and then I'll start talking about the dialog command, which you can use to make your GUI. This assignment should be fairly straightforward, and it should be a lot of fun. Okay, it's going to do a lot. It's going to look like a fairly sophisticated program in the end, and it will be. But a lot of the hard work will be done for you by the dialog command and also by using other bash commands. So you get to think about the design of this program, and you get to implement it. But it starts to move in this direction where so much programming is today, which is you really get to do kind of the creative part, and the lower level nuts and bolts parts, you don't have to work too hard to make those happen, right? This is how like Android development always feels. You type 5 lines of code and boom, you've got something really cool running on your phone, because there's all this support framework in place to do the low level stuff. Alright, so what is homework 7? So you're basically writing a calendar program, something where you can basically set up appointments and then check what appointments you have coming up, delete appointments, and so on. So a reminder program. Let's see, when trying to open homework 7 it says unauthorized. Yeah, so sometimes Canvas does that. Somebody else let me know if you can open homework 7 on Canvas or not. And if not, I'll go ahead and re-upload it. Alright, so you can work in Bash, you can work in groups of up to 4 people. Okay, if you want to work alone, okay, someone else is getting unauthorized. I'll fix that after class then. You can work alone, you can work in groups of up to 4 people. You can work with people from the other section if you like. You just need to coordinate how you're going to do the presentations. And this assignment leaves you a lot of wiggle room. Okay, I'm not going to pin down a whole lot of specifics. I'm not going to tell you how to split up the program. I'm not going to tell you what to call your files and so on and so forth. You get to pick all of that. Okay, so this is a big counterpose to homework 6 in that sense. Okay, so what does your program have to do? It has to run on the Linux server, has to use the dialog command to create a graphical interface, and it has to let the user do 3 things. they can make an appointment on a given date, so they can say, okay, I want a reminder that, next Tuesday I have to, go to the grocery store or whatever. They have to be able to delete appointments that they've made, and they have to be able to see a list of upcoming appointments. All right. I would like command line interactions to be kept to a minimum. This is a bash script you're writing, so it's going to run from the command line. You're going to say something like calendar, or my calendar, and it'll go ahead and run your script. But once the script is running, I'd like everything to be done through dialogues. Okay, so not echo and read, but we're going to use these other interactions to show the user information, get information from the user, and so on. So keep command line interactions to a minimum. And I want your program to save information from one run to another. So if I run your program today and I create a few appointments for myself and I come back in a few hours or tomorrow and run your program again, I should still see those same appointments in my calendar. So you're going to save this information on disk. You're just going to use files to write out the calendar information, and in the beginning of your program you can just read those in. All right. And you get to pick what that file format's going to be. I'm giving you an example of a simple plain file format here where each appointment takes one line of a file, and it's just sort of a date, a delimiter, which I'm using a pipe, a time if you've got times, a delimiter, and then a description of the appointment. All right, but you get to choose that. I've made a accessible directory on the Linux server under /temp called calendars. You can go into that directory and you can create subdirectories of whatever name you like and use that for your group to store their calendar information in. All right. So you've got to do those three things: make an appointment, delete an appointment, be able to look at upcoming appointments. You also need to implement 3 additional features, and you get to pick what those features are. Okay. Some suggestions: being able to edit an appointment that's already been made. So, say I got to go to the store next Tuesday, I can go in and I can change that or add something to it. Or change its date if I want, maybe. Adding a time to appointments. So you only need to implement appointments based on date. You could add a start time. You could also add an end time or a duration. You can check for appointment conflicts. If you have times associated with appointments, you could say, show me any other appointments that conflict with this one, or show me if I have any conflicts. Viewing upcoming appointments or appointments for a given day or for a given range of days would be options. You could add a reminder feature, so when you first run the program, it could tell you, you have such and such coming up in the next day. You could add an alarm feature, so if you know how to use cron, or if you want to learn how to use cron, you can use cron to set up something that runs in the background and wakes up, say, every hour, and it could check your calendar and, I don't know, send you an email or an alert or something like that if you have an appointment coming up. And you can send messages on the Linux server to yourself. You could say write, followed by your username and a message, so you could have a reminder. A pretty advanced option, you could try to work with other calendar programs. So you could export your Google Calendar to an iCal file and then pull that in to your own calendar program. And those are just some ideas. If you have other ideas, right, talk about them, figure out what you want to do, come and talk to me. Let me know what your ideas are, and if I say yes, you can go ahead and do that. Okay, so 3 features from the optional list. All right, groups of up to 4 people. I would like an email on the Linux server by noon this Friday showing me the names of all the people in your group. Okay, full names of each group member. If you want to work alone, that's fine. If I don't get an email from you, I'll assume you're working alone. If you want to work in a group but you're having trouble finding a group to work with, send me an email and say, I want to work in a group, I don't know who to work with. And comes Friday, if I have enough of those, I'll put people into groups. Hold on one sec. Thank you. Yay, package happiness. All right. So that's the group aspect. Submission is due by 8 a.m. a week from Friday, so that's the 13th. So you have about 11 days to do this assignment. And I need somebody from the group to do a Git upload. Call your repo homework 007, make me a reporter, same drill as usual. But I only need one upload per group. If there's more than one, I'll grade whichever one I happen to come across first. So coordinate that. And you can upload to GitLab, just don't make me a reporter unless you want that upload to be the one that I actually look at. So just coordinate who's going to add me to their repository. Or if you're really going fancy with Git, right, everybody can be working with the same repository, which is how it's supposed to kind of work. And then you just have one GitLab repo and you add me as a reporter to that. Totally up to you, okay? I want you to explore the different aspects of this, not just the programming aspects, but the group work aspects as well. Teamwork is a big part of higher level courses in computer science. A lot of your classes at the university level, you'll be working on group projects. So this is a chance to get some more practice with that. Okay, you also need to demonstrate your calendar program to the class. Okay, and these will probably start on the day that the assignment is turned in, which is the 13th of November, that Friday. We'll spell out details of that as we get closer to the date. But I need at least one person from each group to demonstrate to the class. Okay, if you want to share the demonstration, that's fine. So we're all pretty Zoom savvy, and you'll basically screen share and run the calendar program and show us the different features of it. And this is absolutely essential for getting a grade on the project, because I don't know your assignment, and I don't want to have to learn how to use your calendar program in order to test out all the features and so on. So you get to demonstrate this, and based on that demonstration and my looking at the code, you get your grade. All right. So your grading, first of all, to receive any points, you've got to meet the following criteria. Program has to be submitted by Git as required by the deadline. It's got to run on the Linux server. It's got to use the dialog command, and somebody from your group has to present it to the class, okay, during the scheduled presentation times. So if those things don't happen, then nobody in the group gets any points, okay? Assuming you've got those requirements met, your grade is assigned as follows. So if you can make an appointment, 20 points. If you can delete an appointment, 20. If you can look up upcoming appointments, that's another 20. So those three essential actions get you 60 points out of 100. If your calendar remembers appointments from one run to the next, so you're writing stuff out to files, that's another 10 points. And then your optional features, 10 points each. So that's a total of 100 points. All right. This can be a really fun assignment, okay? The dialogue, the GUI part is done for you. We're going to work with that next, but it really takes care of all kind of the hard work of displaying a GUI and picking up interactions from the user. That's just calling Linux commands and capturing the output. That's really just a wrapper on top of a file manipulation program. So if you want to make an appointment, for example, you need to know what date the appointment is. You need to know what the description of the appointment is. Well, in Bash, we would say, what's the date? And we'd say read date. And we'd say, what's the appointment about? And we'd say read description. And then we would echo $date space $description and tack it onto the bottom of a file. Well, exactly the same thing here, except instead of saying echo and read, we're going to use these dialog calls to get that information from the user. But once you have the date and the description and variables, you just echo them to the bottom of a file, and you've got 20 points. Delete an appointment, well, show a list of appointments, and say which one do you want to delete, and the user specifies, appointment 7, and you basically go through and you find that in your file and you just remove it. And we can do that using a command called grep, and we'll talk about that. That's another 20 points. Look at upcoming appointments. Well, just take the contents of the file and run it through more, that would technically get you, you know, a list of all upcoming appointments. There's another 20 points. And then these optional features, right? So adding a time, pretty straightforward. Okay, it's just another piece of information you get from the user. And instead of just storing date and description, store a date and a time and a description. So that's a pretty straightforward one to add. Adding an end time, well, that's just another additional field. And maybe do some check to make sure the end comes after the beginning. Or maybe, you know, get a duration instead of an end time. That's pretty straightforward. And then being able to view appointments on a given date. Ask the user for a date and go through your file, and any appointment that has that date in the beginning, just show that appointment. So finding 3 features from here that don't take a whole lot of you know, really high-level programming should be pretty straightforward. This is all about the wrapper, basically, right? The underlying mechanics will be fairly simple, and the wrapper is kind of where a lot of the creativity goes. Okay? So what you need to do to have fun with this is you need to work with a dialog command up front. You need to figure out what this command does, what kinds of things you can do with it, and the basic interactions. How do you create a dialog? How do you get the response from the user through a dialog? Once you've got those figured out, then you're just writing a script. And at that point, it's really just kind of creative fun. So my suggestion, you know, once you've got a group, play around with dialogue for a while, figure out what it can do, show each other what you've learned, and so on, and then design the overall project. What do we want the interactions to be? We know we got to have these 3 features. What else do we want? What's that going to look like? And, you know, play it out on paper. So if the person does this, this should happen, and if they do that, that other thing should happen, and so on. And then figure out how to split up the work and how to put those pieces together and come up with a timeline. Okay? Don't just, you know, everybody goes off for 10 days and then Thursday night at midnight you get together to put your code together. That's never going to work well. Right? So come up with a timeline that lets you put things back together and test them with enough time to go back and make tweaks as necessary. All right, questions about any of that? So let's talk about the dialog command. So if you're sitting on the Linux server, there's a command available called dialog. If you want to run this on your own Linux machine, sometimes it's installed by default. If not, you can download and install it. Sudo apt install dialog. Let me know if you need help with that. But it's already installed on a Linux server. And basically, this lets us create one of a number of different types of graphical interfaces to interact with a user. So, for example, suppose we just want to display a message. So I can say dialog -- message box. So most switches in Unix that are long, like message box, they take 2 dashes in front to specify what the person wants to do. So we'll create a message box dialog, and you can specify what you want to display in that message box. So I'll just put that in quotes so text goes here, and then height and a width. So I'll make it 20 characters high, 30 characters wide, and there's my message box. And I can say OK and go on. So in my script, if I want to display some information to the user, I can do it like this. Now if you put 0, 0 in for these dimensions, it will make the box the appropriate size for whatever it is you're displaying. So that looks like that. And if I have longer stuff to display, it'll make a correspondingly larger box. And there's an OK button on here. I can activate that with the mouse, or I can activate it with the Enter key, or I can activate it with the space bar. And there's different ways to get to these buttons. Mouse works well from Linux. I've heard from some people that it doesn't seem to work on Windows, so play around with it. And all of these dialogues are heavily customizable. So for example, I can say dash dash OK dash label. And I can change what this OK label is going to be. So instead of saying OK, I can change it to say got it, right? And so now I've got a different button. All right, I can do an info box. And an info box lets you display more information. A message box really displays one line of text, which might, wrap. An info box can display more information. So there's a bigger message, and there's no button required. You don't have to get a response from the user. So if you want to display something and leave it up for a while, you could put a sleep statement after it, and it'll stay there for 3 seconds in this case. And I can break things up by putting in a \n, right? So new line characters work in some places in Bash. And this is just Bash, right? So, I could say my height, I get the height and width confused backwards. I think it's width and height. It's height and width, okay. So I can say my height should be 10 characters, and my width should be 40. And in my dialog, I can use Bash variables to specify the height and the width, right? So you're in Bash. You have all of this freedom of using variables and calling other commands and all kinds of stuff like that. So instead of putting a message in here, I could do something like cow say, this is fun. Right. So think Bash, right? Lots of capabilities. So I can do a yes/no box. I need a title. So that's a meaningless prompt because yes/no isn't a choice really. But and I can use the arrow keys to switch between buttons. I can also use the tab key to switch between buttons, or I can just go directly with the mouse and click. Right? And how do I know what the user chose? Look at your $? variable. So with a yes/no box, if they say yes, $? will be a 0. If they say no, $? will be a 1. So if I want to get some answer, do you want to delete the appointment? I can throw this up, and then I can look at $? and know which button they clicked. I can display a text box, and I can fill that with the contents of a file, so I can look at my bashrc file. And I'll get a big window that contains the contents of that file. So if you want to display a bunch of information, you can put it into a file and then use a text box. And this is a scrollable window, so I'm using my arrow key to scroll down, my arrow key to scroll up. I can hit the N key to go to the bottom, the home to go up. I can go page down or page up, page at a time, and so on. And again, I can set the exit label to something else like continue, and so now my exit label says continue. So I can look at my file, and then when I'm done, I can just click on that. All right, so here's one that'll probably be useful. Dialog -- calendar. Let's just say. put a title on there which says what date. There's a calendar dialog, and you know, you can click through months, you can click through years, you can click through individual dates, and then if you come down to OK, you can select that date. Alright, so you notice that once I selected my date, once I said OK, the program printed this date right here in the middle of my screen. Okay, commands that are going to specify information from the user print that output to standard out, basically. So how do we capture that? We can use back quotes. So remember, there's this idea of saying back quote command, and it basically executes this command and then replaces this with whatever this produces on standard out. So if I say something like x equals back quote, you know, the example we used was x equals back quote print working directory. X is equal to the result of running the pwd command. Okay, so we can do this with our dialog. So I can say my date equals back quote dialog. This won't work exactly like this, though. If I do that, I don't see anything appearing because all that output went into this variable my date. Alright, so here's what you do. This is just a special thing that we do when we run dialog and we want to capture the output. You put the following at the end, -- output -fd1. Alright, if I run that, I get my usual dialog. I can choose November 28th and say OK. And now, if I look at this my date variable, it's equal to 28th November 2020. If I run this and someone decides to, you know, do November 4th, 2024, we'll do the 5th, that'll be our next election day, then that goes into the variable my date. Alright, so this is how you capture the results of one of these dialogues. And that's really all you need. Okay? You can run dialog inside a bash script, which means you can display information, you can display the contents of files, you can display calendars or whatever you like, messages. And if the user is specifying information, clicking on a calendar date, typing into an input box, things like that, you can capture that information by throwing your dialog in back quotes, do this output statement on the end. Alright, and then the rest is just bash. Right, so if statements and calling Unix commands and looping and good stuff like that. Alright, so we'll play more with dialog tomorrow. We'll go through a few of the other interactions. Take a look at the manual page on it. The manual page is huge and takes some getting through, but there's tons of options and features and things like that. And we'll play with this more tomorrow. And we'll also talk about your next ODP. Alright, have a good afternoon. I will see you tomorrow. Thanks.